be going over the Module 3 DBA question examples. So these will be similar to those you'll find that I'll do in the DBA with you. So this first one is asking us to multiply these two radicals, and I'm going to convert them to rational exponent forms. So this first one right here is going to be rewritten as 7 to the 1/4 power, and then we're going to be multiplying that by the second radical, which will be rewritten as a rational exponent, 7 to the 1/2 power. Remember, this 4 comes from right there, and this 1 is because there's actually an exponent there that's hidden. Similarly, the 1 here comes from there, and the 2 is because there's a 2 there that's not written. So that is how we're going to do those. And when we multiply those two bases of 7 with those different exponents, we're going to add those exponents together. So now we're going to be multiplying the exponents. I'm going to rewrite the power 1/2 as 2/4 so that I can add those together more easily. And then that will be 7 to the power 3/4. And that is a simplified version of the original expression. Here, I'm going to rewrite this second radical as square root of 9 times 5, because 45 can be rewritten as 9 times 5. And now I can actually break that square root 9 times 5 up into two parts. So I'm going to break that up into square root 9 times square root 5. Oops, sorry about that. And then the next piece that I can focus on is this square root 9. That's going to be 3. Oops, this is supposed to be addition here. Sorry about that. Addition, because that's this addition right there. Hopefully you caught that as I was doing that. All right, so now we have that first square root 5 plus square root 9 is 3, and then that's going to be times square root 5. And now we can rewrite this as 4 times square root 5, because really this is a 1 times square root 5. And so this 1 and 3 are going to give me a 4 square root 5. And that's a pretty quick explanation of those. If you have further questions, please do ask me during class or anytime. All right, in this one, we are solving each discrete exponential growth or decay problem. So 8 upright dominoes of increasing height are lined up to be knocked down. The dominoes are numbered 0 to 7. The smallest domino, number 0, is 2 inches tall and will be toppled by a person to start the chain reaction. Each subsequent domino is 16% taller than the one before. What is the height of domino number 7? So I think the easiest way to get started on this is to write an exponential function, and the starting height of the dominoes here is going to be that 2. That's the beginning height, 2 inches tall. And then we're going to multiply that by 1 plus, and the second part here that we need to focus on is a 16% increase, which is 0.16. We're going to rewrite that percent as a decimal, and then it's going to be to the power x. X is the number of domino that we're interested in. So now we're going to do f of 7 is equal to 2 times, and I'm going to add 1 plus 0.16 to just be 1.16. We can write it either way, it's fine, to the 7th power. Now I'm going to bring up a calculator here, and we're going to do 2 times 1.16 to the power 7. And that will give us about 5.65, and that's an estimate, showing that it's an estimate, not an exact answer, 5.65 inches. And that is how we do that one. Rentals in a high-rise apartment building get more expensive higher up since the views get better. The ground floor, floor 0, rent is $1,080. The rent increases 4.5% per floor. What is the rent on the 6th floor? So now we need to be careful here because this looks like it was maybe written in a country different than the United States. There are some apartment buildings that use the ground floor as floor 0 and the first floor as the one up. But I think on the West Coast, we often talk about the ground floor as the first floor. So it's just something to be aware of here. So we're going to start out though with again, we're going to have a function, and I'll call it g of x this time. No reason why. It doesn't really matter what the name of the function is. The starting value of 1080 is right here, and then we're multiplying that by 1 plus the percent increase. The percent increase is that 4.5%, so it's going to be 0.045. Now be careful that you write that like this with a 0 here after the decimal. That's 4.5%. If it were 0.45, that would be 45%. It's a mistake I see students make quite often. X is the floor that we are interested in. So now we're looking at g of 6 equals 1080 times 1.045 to the 6th power. So again, we're going to pull up that calculator and get it out of the way a little bit. So it's 1080 times 1.045, and let's see, sorry, to the power. Whoa, I just messed that one up. Let's try that again. 1080 times, oh, I think that I see what I'm doing. Sorry about that. 1080, and I'll go down 1.045. When I push shift, it messes things up to the power 6. And that will give us about $1,406.44. All right. So this is approximately $1,406.44. An architect is designing a tapered office tower where the ground floor is the largest and the floor space is reduced by 7% per floor. If the ground floor has an area of 14,200 square feet, what is the area of the 6th floor? So what does it mean to be tapered? Well, it means that it looks like this. So the building gets smaller the higher up you go. So again, here we're going to have we'll do f of x again. And I hope you're seeing the pattern here that the whatever the starting value is, the value at when x is 0, that goes first here, 14,200. And then we do 1. And this time we're not increasing, so we don't have a percent increase, we have a percent decrease. So it's going to be a subtraction because it's reduced, so it's a percent decrease. And we're going to then subtract from that 7%, which is going to be 0.07. Again, 7% is 0.07. Sorry about that. And we're raising that to the x power. And so in this case, we're looking at the 6th floor, 14,200. And that's going to be 0.93 when we subtract 0.07 from 1. Notice that because it's a percent decrease, it's a reduction, this is less than 1. Here, it's an increase, it's greater than 1. Here, an increase, also greater than 1. And that is always going to be the case. So let's grab that calculator. And so we have 14,200. We're going to be multiplying that by 0.93 and raising that to the power. Oops, I think that was going to be 6, right? And let's see what that comes out to be. So that's going to be approximately 9,187.3 square feet. All right. For tax purposes, a car rental company assumes each car in their fleet depreciates by 10% per year. Depreciates, that goes down. So we're going to have subtraction instead of addition. If the initial value of a car is $36,600, what will the value be when the car is 9 years old? So again, let's do, we'll do C of X for like the car. So that's the car's value is equal to the 36,600 and then that's going to be times the quantity 1 minus, because we're depreciating and we're depreciating by 10%, so that's going to be 1 minus 0.1, and to the x, which is the number of years, we're looking at 9 years, so C of 9 is equal to 36,600 times 0.9, again less than 1 because we're depreciating, to the 9th power. So we have 36,600, and we're going to be multiplying that by 0.9 to the power 9. So that car is going to be, after 9 years, that car's only going to be worth about $14,179.60. And that probably is not terribly inaccurate. The value of cars goes down significantly over time. So $14,179.59. Now, so those 4 word problems are a really important part of this module. It's important to know how exponential functions show up in real life. So rewrite the function so that it only has the variable x in the exponent. So right now the exponent has a 3x in it. So how do we change this so that it has just a x in the exponent? Well, what I know is that I can rewrite this so that we have 2, and instead of this multiplication, I'm going to use parentheses here, times 1.5 to the power 3 all to the power x. So notice that what I did was I took this 3x, and the 3 becomes the exponent on the original base, and then all of that is raised to the x. So if you wanted to go from this to that, you could do that, which means that if you wanted to go from this to that, you can also do that. And when I do 1.5 to the power 3, I'm going to get 3.375. So I'm going to take this part right here, and I can show that it's equal to 2 times the quantity, 3.375 to the power x, and that is written the way that the problem asks us to write it. Which function has a larger percent of increase? Well, the percent increase that we're talking about is going to be here, and the percent increase on f is going to be a 50, whoops, I'll put it in blue, is a 50% increase, because this can be 1.5 is equal to 1 plus 0.5, which implies a 50% increase. So I'm going to highlight that 0.5 is a 50% increase. On the other one, 1.07 is equal to 1 plus 0.07, which implies a 7% increase. And we can see that 7% right there. So that means that f has a larger percent increase, because 50% is greater than 7%. All right. DeAndre deposited $5,000 in a bank account with an annual interest rate of 3% compounded annually. The equation below shows the value of her investment after X years. So the initial investment of $5,000, the 3% is the 0.03. We're adding it because it grows. We're growing, it's not depreciating, it's appreciating. What was the average rate of change of the value of DeAndre's investment from the 3rd year to the 7th year? So what we have to do here is we have to find out, we have to find f of 3, and we also have to find f, well, let's just do f of 3 first. So I'm going to bring my calculator back over, clear that. So we have 5,000, and I'm just going to do 1.03 to the 3rd power. And so that's going to equal 5,463. And actually this should have been an estimate, because there's a 63 cents, 63.5 cents. So I'm going to say 64 cents. And then we're also going to need to find f of 7. So I'm going to go back up and grab that, go in and change this to a 7, and it's going to equal approximately $6,149.37. Now we're going to take the first value there and the second value, and we're going to subtract. We're going to do $6,149.37 minus the $5,463.64. So we're going to do 6,100 $6,149.37 subtract $5,463.64. And what did I do? Oh, yeah, subtract, not negative. And that's going to equal $685.73. Now, so that's the how much the value changed over the course of those 4 years, from year 3 to year 7. Maybe that's 5 years. Let's see. Third year, fourth. 3 to 4 is 1. 4 to 5 is 2. 5 to 6 is 3. 6 to 7 is 4. So it's 4 years. And I could have just done 7 minus 3. So yeah, so 7 minus 3, because we're talking about from year 3 to year 7. So now we have to find the average. So $685.73 divided by 4. So I'm going to take that and divide by 4. And I will get approximately $171.43 per year. That's the average. All right. Now on this one, what is the percent decrease represented by the coordinate points? So assuming that all of these y values are decreasing by the same percent each year, we can just look at the first ones. 300 divided by 500. So I'm looking at, whoops, I didn't do divided by. 300 divided by 500. It didn't again. All right, I'm going to need to use this. Let's try that again. 300 divided by 500. So it's going to be 0.6. So what I'm using is I'm using the 300 and the 500. 300 divided by 500 is equal to 0.6. That actually means that what we're looking at is we're starting out, we have a function, f of x is equal to 500 times 1 minus 0.4 to the x power. So that means, and the way that we got that is because 0.6 is equal to 1 minus 0.4. And that means that we have a percent decrease of 40%. All right, number 11 here. When the function f of x is equal to 3 times 5 to the x power is changed to f of x is equal to 3 times 5 to the x power plus 7. So what we've done is we've just added this 7 here. What is the effect? Well, what we're doing is we're taking the original function. Really, it might have been nicer if we had renamed this g of x. So we're taking the original function f of x. So g of x is equal to f of x plus 7. And remember that this is a y value. So what we're doing is we're taking the y value and we're adding 7 to it. And we're taking all of the y values and adding 7. So that means that the entire graph is moved up 7. The y values are increased by 7. And that's what happens. So it takes the whole graph and it moves it up 7 units. All right. We're going to graph the function. So the first thing that I see here is that we have a starting value or a y-intercept of 2. So on the graph here, I can go right here and say, all right, I know that's where we're starting. And then the 3 here tells me that every time I move 1 unit to the right, I take this value and multiply it by 3. So 2 times 3 is going to be 6. So my second point will be right here. And then again now, 6 times 3 is going to be 18, so it's going to be up there. So it increases really fast. And as I move to the left, I take the y value and I divide by 3 instead of multiplying by 3. So 2 divided by 3 is 2/3. So that's going to be about right there. And then it's just going to very slowly get smaller and smaller and approach that x-axis that way. So let me see if I can do a decent job of drawing this graph. I don't know, it's pretty rough. There we go. It's going to go off like that forever. So that is going to be the graph. So I take this again, the 2 tells me the y-intercept. The 3 tells me take the y value. When I move to the right one, multiply the y value by 3, it'll be 6. When I go to the right one, take that y value of 6, it's going to be 18. If I'm moving to the left, take the y value 2, go to the left 1. 2 divided by 3 is 2/3. All right, now here we have notice that this one, our multiplier was greater than 1, so we were increasing. Here, our multiplier is less than 1, so we're decreasing. So what we have is our initial starting value of 2. That's right here. Whoops, let me do it in blue. 2. And now, as we move to the right one from here, we take the y value and we multiply by 1/2. So 2 times 1/2 is 1. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. And now you can see it's just going to be getting closer and closer to that x-axis. And we move to the left one. Dividing by 1/2 is the same as multiplying by 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And then we're going to be going off of the graph there, so it's going to gets really big as we move to the left there. Now if we're going to connect all those, it's going to go off like that. And that is the last one for these problems. I hope this is helpful. I will see you all soon.